Hello, my name is Andrew Kucher, and I'm going to be solving problem 12.38 from Fundamentals of Heat and Mass Transfer by Bergman and Levine. Now, for this problem, as you can see in my graph, we're essentially given a spectral chart of the irradiation happening to an opaque surface. Um, we're given the temperature of the surface, but aside from that, not much else. But some assumptions that we can make about this surface are that, well, obviously it's opaque, and as a result, we can assume the emissivity in the spectra is equivalent to the absorption in the spectra, and also the solar. Essentially, we're also going to be assuming that the irradiation happening on the surface is equivalent to the radiation you would be receiving from the sun, which is why you have the energy of the lambda beta of the emitting body essentially is at 5800 K. Now, to get the solar absorptivity, basically, what we're trying to find is the solar absorptivity and total hemisphere emissivity. Sorry if I didn't say that earlier. Now, for the absorptivity, it's this equation right here, this A alpha S. Um, This can be way more simplified by using table 12.2 in the book, where you will see, oh, that doesn't look pretty, this chart. So this chart is very helpful in solving this, as it essentially lets us not allow us to not do an entire integral, or a series of integrals possibly. So this basically allows us, especially using this spectral chart, to divide up the spectral chart into separate chunks and then determine the result of that integral essentially from that chunk, and then we can add those up separately. So we're doing that in the 0 to 0.3 range, and then also 0 to 1.5. As you can see here, we have alpha 1, which is this side of the chart, um, alpha of lambda, and this is the spectra, so that's why this is lambda. It's the wavelength of the light. So we have alpha 1 times the F value from this table, um, time from 0 to 0.3 plus the alpha 2, the value at this 0.9 here. Alpha 1 is 0. Alpha 2 from 0 to 0.5 minus 0 to 0.3. So we're just looking at this section. And then alpha 3 from 1 minus f of 0 to 1.5. So this entire section of the chart here. So as you can see, from doing to get the F value, we need to multiply the spectra of the light by the temperature, which in this case, the temperature is that of the sun, so 5800 Kelvin. And then in this case, we have 0.3 as the maximum and 1.5 as the maximum. So 0.3 times 5800 gets us 1740, which in the chart on this side gets us an F of, well, you'd have to do a little bit of linear interpolation to get that, but um, the F value is 0.0335. Um, but as you can see, yeah, it's in between those two values, but close to 1800. Doing a similar thing for the 1.5, you get 8700 um, mu meters Kelvin. And that net gives you a value for F of, again, doing a little bit of in linear interpolation, about 8.89, significantly larger, 0.88 specifically. Um, Now it's just simply plugging in the numbers because the value of alpha 1 is 0, that doesn't matter. So you're basically just subtracting 0.88 from 0.0335, and multiplying it by 0.9, which again is the spectra, the alpha of the spectra. And then adding the other value, 1 minus the 0.885, which gives you an absorptivity of 0.774. Now, for the total hemisphere emissivity, this equation is also from the book. Specifically, this equation is, just give me a second to look it up. This is equation, oh, okay. It doesn't stay. Okay, never mind. Uh, Anyways, it's a derivation and similar form of equation as the absorptivity. And you solve it in a very similar way. So instead of again using the integration by hand, we're using the F terms. And from 0 to this time, however, because it's for the body, we're not using 5800, we're using 240 Kelvin. And from 0 to 1.5 is 1.5 times 340, which is 510. Oops. Which, looking at our table, 510 is 0. It's basically 0. So that term basically falls off. So the only term that would matter is the term at the very end, this off to infinity, off to the right here for the spectra. So as a result, the emissivity, the total hemispherical emissivity is equal to the absorptivity, of the spectra after it basically goes off towards infinity, which is 0.1 in this case. So the total hemisphere emissivity is also 0.1. Thank you for listening. Have a nice day.